This video covers Module 4 Part C, Data Analysis Beyond Descriptives. In this video, I will talk about the data analysis that we need to do in order to address our research objectives for the quantitative report. It moves beyond just descriptive statistics, which is describing our sample as talked about in the previous video, and starts to elaborate on inferential statistics, which is where we look at our sample and infer something about the wider population based on characteristics of our sample. We'll look at doing group comparisons and use a technique called t-tests, and we'll look at relationships between our variables using correlation, which we've already talked a little bit about in the earlier part of this module. So to begin with, we'll start to examine or address objective 1, which is where we're choosing two segmentation variables and we're reporting on potential differences between groups using t-tests. So if you look at the front of the analysis document, that's described here. A reminder of what our objective is. It's to examine if attitudes towards smartphone shopping differ across population segments, and your task is to choose two segmentation variables of the four that we measured. So the four that we measured were age cohort, gender, relationship status, and communication preference. You choose two of those and then report the results of a t-test for each one corresponding to each of those segments. So what you can do is think about what sort of differences you might expect. If you think about gender differences, would you expect there to be a difference between men and women in terms of their attitude toward online shopping? And which direction do you think that difference would be in? Do you think men would have a more favorable attitude or women? We can look at that numerically, but we're going to look at it statistically. So we do that by running what's termed a t-test, or what's called with a technique called a t-test. A t-test is used to determine if two groups are statistically different from each other. So they might appear different within our overall sample if we just look at the means, but what we want to know is whether or not that difference seems like it would be representative of a difference within the wider population, or not, because it may have occurred just within our sample just by chance or just due to random sampling error. So for example, we might have hypothetical data such as this here, where we've got attitudinal ratings and we can see that overall male scores listed here or depicted here in blue, and female scores depicted in red, where we say the mean for males appears to be about 4.1 and the mean for females appears to be about maybe 4.6, 4.7. You could look at those two means and say numerically they appear different. 4.1 appears to be smaller than 4.6 or 4.7. Males therefore have a less favorable attitude than females. That might tell us the overall difference in means within our sample, but we're interested in whether that's likely to be representative of a difference within the wider population. We have to be cautious of concluding that, though, because we know that in the wider population there's going to be potentially more variability, and that with our sample we may have just selected a very specific sample. So what we need to do with our sample is consider not only the difference between the means, but the underlying variability associated with each of those means. So think back to the previous video where we talked about the normal distribution, so scores being normally distributed, and also standard deviations, which correspond to how widely spread scores tend to be around those means. If we've got a very wide standard deviation, or large standard deviation, we'll see a wide distribution, and a very small standard deviation, we'd see a very narrow distribution around those means. If we know that there's a lot of variability around those means, what that indicates is there's probably a lot of variability in the population that we've drawn that from, and the next time we draw a sample, chances are the mean won't be there. The mean will end up down here, or the mean for males may end up higher than females. We don't necessarily know that. So we need to take into account the amount of variability. If there's only a very small amount of variability, that means the next time we draw, or that suggests that the next time we draw a sample, our mean for males may end up in roughly the same spot. And similarly, if the mean for females is here, and we've got a very small amount of variability, then the mean for females will end up in roughly the same spot, and we might be more likely to therefore infer that the difference between those two groups is more reliable. So what a t-test takes into account is not only the difference between these means, but also the variability in the underlying distributions. And it does this by creating a ratio calculation in the form of a t-score. You can see that represented conceptually here. There are actually quite specific formulae for the different types of t-tests, so this is just conceptual, and it's saying the difference between means is what we're comparing to the amount of variability in the underlying distribution. So if this difference up here is very large and we have a very small amount of variability, then we'll get a large t-score. And if the difference between the means is small and we have a very large amount of variability, we get a very small t-value. When we run a t-test, we get a table of output or a couple of tables of output, but the things of interest in that table to us, or the values of interest to us in that table, are our overall t value or our t-score and the corresponding significance level. If we're hopeful to see a difference between the two groups that we're comparing, then what we would expect to see or hope to see is a large t-value. Large t-values are associated with small significance levels. Most researchers, or most quantitative researchers, when they run this sort of test, will intuitively or instinctively look to the significance value to see whether or not that's large or small. The way we can read a significance level is like a probability. So we can say that here we've got 0.000. This is actually a very small probability, and you can consider that or read that as the probability or the likelihood that the difference of the size we observe back here is likely just due to random sampling error. So if that significance level is small, what we're saying is that there's only a very small likelihood that the difference back here occurred due to random sampling error. It's probably a true difference. In contrast, if our significance level is relatively high, in this case it's 0.436, and here you can see we've got only a very small t-value, what that indicates is that we've only got a small difference back here or a lot of variability, and therefore there's a higher probability that any difference that we observe is just due to random sampling error, or getting a difference of that size or that magnitude is likely just due to random sampling error. So you can read these as essentially probabilities that we'd get a difference that big just by chance. If we're hopeful for a difference, we want a small significance value. So I guess the question arises from that: what is a small significance value versus a large significance value? And by convention, what we do in quantitative research and in the social sciences, psychology, and business is use a cutoff level of 0.05. We say a small significance level is any value lower than 0.05, and a large significance value is any value larger than 0.05. So we would say that if our significance level is below 0.05, that it represents that there is a true difference. If it's above 0.05, it's probably not a true difference. That's probably just occurring just by chance. One important thing to note is that within SPSS, it truncates this value to 0.000. A significance level can never actually truly be zero. So that's probably something like 0.000007 or something like that. So this should actually have a value. It's not actually truly zero. So to summarize that, when you run a t-test or any sort of statistical test that has a significance level, most researchers will look to that significance level. If you're hopeful to see a difference or be able to infer that there is a difference between groups, you would be hoping to see that that's below 0.05. If it's above 0.05, you'd say that there's no significant difference.
Right, so let's have a look at that within our actual SPSS data file to see how a t-test is run. And And what you do is, again, go up to Analyze, which is where all the different techniques are available to you to run. Go down to Compare Means, because we're comparing the means across two groups. And we're going to select Independent Samples t-test. An Independent Samples t-test is one of the most common types of t-tests to run. It just refers to the groups that we're comparing being totally independent from each other. So men being independent from women, someone's not in both groups. Younger people versus older people, for example, would be two independent groups. People aren't in both the younger and older group. Those groups are considered independent. The other type of very common t-test is a paired samples t-test, and this refers to the situation where you have the same people in each of the two groups. So it might be measuring someone, a group's before an exercise program and after an exercise program, or before exposure to a social media or a social marketing campaign and after a social marketing campaign, to see how their behavior changes on some particular dimension. Right, so for ours, we're going to run an independent samples t-test. So you select that and you'll get a dialog box that appears like this one here. You're going to select your grouping variable, which is basically saying what the two groups are. And for our first analysis, we're going to look at a cohort difference, so the grouping based on whether people are in the younger or older cohort. So you pull that down or arrow that down into the grouping variable cohort. You select define groups. This is where you're going to tell SPSS what the groups were labeled, or how those groups are coded in the data set. So think back to the variable coding document, where we have cohort younger and older, the younger and older groups within the cohorts coded as 1 and 2, men and women coded as 1 and 2, single versus partnered people 1 and 2, and so on, and you just list those here, 1 and 2. That becomes much more important if you have more than, say, 2 groups within your data set and you want to compare different groups. So if you had 3 groups and you wanted to compare 1 and 3, you'd enter 1 and 3 in the comparison. Alright, so our groups are labeled 1 and 2 for younger and older, so we select that there, and in the test variable we indicate or take across what it is that we want to see whether or not those groups differ on, and in our case it's attitude towards smartphone shopping, the behavioral intention variable. We simply click OK, and you get an output that looks like this, with 3 tables, and the first 2 are the ones we're particularly interested in our case. The first table is basically a descriptive statistics table of those 2 groups, and then the second table is our t-test output table. So looking at that first table to start with, you can see they've got the number of people within the younger and older groups, just like we saw in the previous video, the counts of those, the means and the standard deviation. So if we just look at the means here, you can see the mean for younger people looks to be higher than the mean for older people in terms of that attitude variable. So within our sample we can see that the means appear different, but what we want to know is, taking into account the underlying variability, so the standard deviation, is it the case that we would expect that's representative of a difference in the wider population. So we look down now to our independent samples t-test output. You can see a t-value listed here, which is fairly large, and then an associated significance level, and in our case we'll look at the two-sided significance level. And here it is less than 0.001, so well under that 0.05 cutoff. So what you'd say is that the difference between older and younger groups appears to be a significant difference. Therefore, within the wider population, we expect that younger and older people have differing levels of attitude towards smartphone shopping. Let's run another one of these, this time with, say, our gender variable or our sex variable. So we go to Analyze, Compare Means, and Independent Samples t-test. All we're going to do is switch out the grouping variable to our sex variable. So we scroll down here, you take sex across into the grouping variable, define our groups as 1 and 2. Again, males versus females. We click OK. Okay, and then you can see the output for that listed here, our descriptive statistics in the first table and our t-test output in the second table. You can see in the descriptives we've got 240 men and 193 women. The means are looking much closer here, so 4.67 versus 4.76. So possibly a difference. We don't know. If we look at that, some people might call it a difference, some people might not, and that's why it's really important to have a fixed rule or a statistic that will tell us whether or not that is considered a difference based on convention. So look down to our statistical test or our t-test results. We see we've got a very small t here. It's a negative 0.540, so it's quite small, and the associated p value or significance level is listed here at 0.589. That's well above 0.05, so what we would say is that's a non-significant, that indicates no significance. So we'd say here, regardless of any difference that is apparent, we wouldn't interpret that as being representative of a difference within the wider population or a broader population. So this is a good example of what we might see when a result shows up as non-significant. Now, in terms of what you need to do for your report, if you go back to the actual analysis document here, and scroll down here, you can see that you're going to choose 2 segmentation variables of the 4 that we measured. So age, cohort, gender, relationship status, or communication preference. And if you scroll through the analysis document to that section, or the section on objective 1, you can see we've got the 4 t-tests associated with those 4 comparisons listed here. So you've got the t-test results for the difference between younger and older people listed here, the t-test results for the difference between men and women listed here, then t-test results for single versus partnered people, and t-test results for those who prefer email versus online chat. So you're going to choose 2 of those and write up the results of that. So all of that is summarized for you in the analysis document. And this slide summarizes exactly what you need to do to write that up within your report. So you need to report the results of the t-tests of your 2 chosen variables, and to do that you provide the means of the groups being compared, the t-value, and the associated significance level. I'm quite conscious that not everyone has written up quantitative or statistical results before, and those are actually written up really quite succinctly in short, sharp sentences in very specific ways. So unlike qualitative results that can take pages and pages to write up, stats tend to be written in very short, sharp sentences that tell the reader exactly what the stats were, because that's objectively what a reader needs to know. So to avoid people taking pages or paragraphs and paragraphs to write that up and not really knowing how to do that, I've provided a little bit of a template here, and you're welcome to use this template or adapt it to your own words. But essentially what you need to say is something like the mean attitude for group A, say it's men and women you're comparing, the mean attitude for men was whatever that was, while the mean attitude for women was, and whatever that was. Assuming equal variances, a t-test showed that the difference between the means for men and women was or was not significant, and then within brackets you'd write what the t-value was and what the associated significance level was. Now, better performing students will obviously go on and interpret that a little bit more. So rather than just providing that technical detail, go on to provide a sentence or 2 saying exactly what that means in everyday language. So this indicates, for example, that men and women differ in terms of their attitude towards smartphone shopping. The technical way to write up t-test results isn't to say t-value equals and significance level equals. However, for the purposes of our assignment, I'm okay for you to do that. If you do want to write that up more technically, you can follow this notation here. So what we would typically have with a t-test is an italicized t equals, and then whatever the t value was, and then comma, an italicized p for significance level, or probability is where the p comes from, an italicized p equals, and then whatever the significance level was. Now those numbers are not italicized, so just got to unitalicize those, and you'd put those in brackets. So you're welcome to use that more technical notation, or simply write t-value equals significance level equals. I'm not particularly concerned which you do. The other thing to be aware of here is that within this template here, I've written or I've indicated that you should write, assuming equal variances, a t-test showed that the difference blah blah blah. So this assuming equal variances is important to include, because it will tell the reader which part of your SPSS output you're referring to. So if you go back here to some t-test results, you can see that we're using the top row of data and that there's another row underneath it. That top row of data refers to the idea that we are assuming equal variances between the groups that we're comparing. And then if we weren't assuming equal variances, we'd use that second row of data. Where that comes from is if we go back to the t-test diagram here, you can see that we've got roughly an equal or similar distribution for men and for women. If it were the case that we had different distributions, so for example men had a really tall skinny distribution, and for women there was more of a flat wider distribution, we'd say that those are two different distributions that we're comparing, and in that case SPSS has to make a little bit of an adjustment with the type of analysis it's doing. And in that case you'd use the bottom row of data, which is not assuming equal variances. SPSS will conduct a test and tell you which to use, and that test is listed here. It's an F test based on Levene's test of equality of variances. For our purposes, we won't worry too much about that. We will simply use that top row of data, and hence this assuming equal variances a part of the sentence there. All right, so that's basically what you need to do to write up the t-tests for your two chosen variables in order to address objective 1. Now, it's not necessary to think about for our report, but often you will want to compare more than two groups. So we're just looking at older and younger people and men versus women, but sometimes you might want to look at multiple groups, more than just two. So it might be younger people, middle-aged people, and older people, or it might be people on lower income, middle income, and higher levels of income, or you might have 4 or 5 groups. When you want to compare more than two groups, you use a technique called analysis of variance, and that's usually abbreviated to ANOVA. So just be aware that there are more advanced techniques out there as well, and that's a technique that we go into in a lot of depth. It's a widely used technique, it's a very popular technique, and it's one that we go into a lot more in depth in our subject AMB 305, Analysis for Consumer Insight. So if you are curious about that or want some additional insight, just remember that you can do that subject in the future. In terms of objective 2, this is where you're going to start to use a different type of analysis technique, and this is where we're going to rely on correlation, which is what we discussed in the first video of this module part A, correlation. So for objective 2, remember, this is where you're going to try to understand the relationships between individual characteristics and attitude towards smartphone shopping, and you're going to choose 2 of the 8 that we measured. So remember, we measured convenience seeking, risk aversion, impulsiveness, price consciousness, enjoyment, control, social orientation, and task orientation. You're going to choose 2 of those. So for example, it might be price consciousness and enjoyment, or it might be social orientation and task orientation, and you're going to talk about the correlations between each of those constructs and attitudes toward smartphone shopping. In thinking about which ones you want to choose, what I would say is think about what story you want to tell across your report. So think about your report as you communicating a story to a reader rather than just presenting some results to the reader. So what story is it that you want to tell across your report, and then choose the ones that tell that story or help you tell that story. You're going to report the correlations between attitudes towards smartphone shopping and each of your 2 individual characteristic constructs. So a bit of a reminder, so correlation is just looking, analysis is an analysis technique that just looks at the extent to which 2 variables relate to each other, or how they change with each other. As one increases, does the other increase as well, or does the other one decrease, or is there no real relationship between them? So if you're a little bit grey on that or forgotten about that, go back and look at Module 4 Part A and review that content where we discuss correlation in relation to grades and student attendance. As outlined in that module or that part of the module. SPSS will give us correlation coefficients that help us to understand the direction of the relationship. If it's a positive direction, whereas one variable increases, the other one also increases, or if it's a negative relationship, whereas as one variable increases, the other one decreases. It'll also provide us with an actual number, we call that a coefficient, that tells us the strength of that relationship, and that'll be an absolute value between 0 and 1. The closer to 0 it is, the weaker that relationship is, and the closer to 1 or negative 1 in the case of negative correlations, the closer to 1 or negative 1 it is, the stronger that relationship is. So the more clustered around the diagonal they tend to be, the clearer that relationship is. And then SPSS will also tell us the significance of that relationship. So that will be a value similar to the significance levels we just talked about with t-tests, that will allow us to determine or judge whether or not that relationship is likely just due to sampling error or just due to chance, or if it's more likely a true relationship. So this slide here shows the different types of patterns that we can get, and you can think about in relation to the individual characteristics that you want to examine what type of pattern you might expect. If you're unfamiliar with these, go back to that first video and have a bit of a look. But for example, you might think for something like convenience seeking. The more someone values convenience, the higher the likelihood of them also having a positive attitude towards smartphone shopping. So you might think about a positive relationship. For something like task orientation, it might be a negative correlation, or it might be a positive correlation. So think about what you expect prior to looking at the results and thinking about which ones you want to choose. Once you've got your characteristics though, and you're going to be reporting them, you will be reporting on each of those things: the direction of the relationship, if it's positive or negative, the strength of that relationship, and then also the significance. Now, when we're thinking about the strength of the relationship, remember SPSS will tell us an actual number. You can think about classifying that as weak, moderate, or strong. Now, these classifications, we've said weak is anything less than 0.1, moderate is between 0.1 and 0.5, and strong greater than 0.5. These classifications really vary depending on the discipline that you're in and the context that you're looking at. So in something like consumer behavior, we typically would use classifications like this, whereas something like medicine, you might have much more nuanced classifications. In terms of the significance level, we're again going to be using 0.05 as our cutoff. So anything significant will be where our significance level is below 0.05, and anything that's non-significant, we would consider that where it's above 0.05. Looking at our own data here, you can see the first column of a correlation matrix, which really covers all of the information that we need to see. So we've got the relationship or the correlation between attitudes towards smartphone shopping, the behavioral dimension, as correlated with itself, as correlated with convenience seeking, as correlated with risk aversion, impulsiveness, price consciousness, and so on. And I'll show you how to run this in a second. Let's just go through some of the detail here that we can see. So firstly, looking at convenience seeking and the relationship between it and attitude towards smartphone shopping, we've got the Pearson correlation, which tells us the level of that correlation. You can see the strength and direction shown here with this number. So it's a positive number, it's a positive correlation, and it's moderately strong because it's 0.38. If you go back here, you can see 0.38 falls between 0.1 and 0.5, so it's a moderately strong correlation. It's a positive correlation, and the significance is less than 0.001, so that's less than 0.05, so we say it's a significant correlation. So there is a correlation between convenience seeking and attitudes towards smartphone shopping. It's moderately strong, it's positive, and it's significant. And down here you can see the number of people whose data fed into that relationship. For risk aversion, similarly, here you can see the strength and direction of that relationship. In this case, it's negative. Again, it's moderately strong, and it is also significant in that the significance level is less than 0.001, which is well below the cutoff of 0.05. So when we're talking about positive correlations, So with convenience seeking, it would look something like this, and then with risk aversion, you've got the reverse where it would look something like this. So when we've got a positive correlation, what we would say is as people's orientation towards convenience seeking increases, so too does their attitude towards smartphone shopping. And with risk aversion, as people become more risk averse, their attitudes towards smartphone shopping tends to decline. Looking down here, you can see something like price consciousness has quite a low Pearson's correlation coefficient, so it's positive, and it's quite small at 0.075. And if we look at the significance level, that's well above 0.05, so that one we would say is not significant. Any apparent relationship there may as well just be due to chance. So therefore we'd say it probably looks something like this. The level of price consciousness that someone displays isn't necessarily related in any significant way towards their attitude towards smartphone shopping. So you can see all of the data there. So let's look briefly at how to run this within our SPSS program. So what you would do is go to Analyze, Correlate, and then Bivariate, a bivariate correlation, so bi meaning two. And what you do is go down and include all of the variables that you want to use or include in a correlation matrix. So our attitude variable, our convenience seeking variable, risk aversion, impulsiveness, price consciousness, enjoyment, control, social orientation, and task orientation variables or constructs. Take those across to our working window and you click OK. You can see you get a full table like this that correlates everything here with everything else in the table, so that down the diagonal you see perfect correlations where price consciousness correlates perfectly with itself, enjoyment correlates perfectly with itself, and so on. So essentially all you need to do is look at this very first column where you're correlating attitudes towards smartphone shopping with all of the other variables, which is what was on the previous slide. So that's how you run that correlation.
In terms of writing that up, what you're going to do is report the correlation analyses for your two constructs of interest. So whichever two you've chosen, you're going to provide the correlation statistic. You're going to comment on the strength, the direction, and the significance. And again, just like with a t-test, there's a very succinct way to write these up. So you would say something like, results showed a significant correlation or a non-significant correlation, if it's not significant, between X and Y. So it might be between attitudes and risk aversion, or between attitudes and social orientation. You provide the correlation statistic and you provide the significance level. And just as I said before, with giving that everyday summary in everyday language, that's where the better performing students pick up grades, because that shows that they understand what they're talking about rather than just putting in words to the template that I've given you. So they'll go on to say, this positive or negative correlation indicates that as people have a greater appreciation or a more favorable attitude towards smartphone shopping, they also tend to rate higher on control or enjoyment or whatever. In terms of the technical way to write that up, instead of a T for a t-test, with correlation you use a lowercase italicized r, and again you use P for significance level. So you would put something like 0.1, 2, 3, comma, and those are not italicized. And the R is italicized, the P is italicized, but the numbers aren't. And then your P value is 0.001, and you'll put that there as well. So that's essentially what how you'd write that up in more conventional notation. If you don't want to do that, or you're unfamiliar with what to do, you can just write correlation statistic equals and significance level equals. It's up to you. All right, so that's objective 1 and objective 2. Remember, objective 1, 2 t-tests, objective 2, 2 correlations, and then objective 3 is going to be quite an interesting objective. This is where you're again going to use correlations, but here we're going to look at attitudes between smartphone shopping and then how that relates to people's attitudes toward online shopping. And you kind of expect those to be similar, and how that relates to people's attitudes toward traditional shopping. Right, so summary here from the front of that analysis document. The objective is to evaluate the relationships between attitudes towards smartphone shopping and general attitudes toward other modes of shopping, so online and traditional. You're going to consider both of those modes of shopping, and then you're going to report the results of the correlation analysis between attitudes towards smartphone shopping and each of those. So
think for a moment about what that actually means. So if someone values smartphone shopping, do you think that that would relate to how they value online shopping in general, or do you think that that would work in reverse? And then what about traditional in-store shopping? Just because someone feels favorable towards smartphone shopping doesn't necessarily mean that they feel unfavorable towards traditional in-store shopping, or is it likely that those two things would both be positive together? We do know that a lot of people use smartphones while they're shopping in-store nowadays for price comparison and convenience. So perhaps those things do relate to each other. And you can think about the implications for that. So if it's the case that people who like to shop in-store have an unfavorable attitude towards smartphone shopping or a favorable attitude towards smartphone shopping, how does that impact on what marketers should do, or how marketing campaigns should be promoted?
So in terms of our data, what we can see here this time is a smaller correlation matrix. So you've got attitudes towards smartphone shopping as correlated with general attitudes toward online shopping and general attitudes toward traditional shopping, and the different statistics associated with each of those here. So with online shopping, you can see that the Pearson's correlation is quite high and it's positive. So we've got a positive relationship, something that looks like this, and it's 0.641, and it's also a significant relationship. The significance level is below 0.05. So if we scroll back to the numbers way back here, we can see that it's actually considered a strong correlation, in that it's greater than 0.5. And it's positive relationship. So there's a strong positive relationship between attitudes towards smartphone shopping and attitudes toward online shopping. If we look at the next one though, attitudes towards smartphone shopping and attitudes towards traditional shopping, you can see it's a negative number and it's very small, and it's actually a non-significant correlation. So the significance level is well above the 0.05 cutoff at 0.665. So what we'd say is any apparent relationship here is just due to random sampling error or chance. You probably have a pattern that looks like this. It doesn't appear that there's any relationship between people's attitudes towards smartphone shopping and how they feel about traditional shopping. It's quite an interesting pattern. So think about those two relationships, and you're going to report on those. In terms of writing that up, you're going to report on the results of the two correlation analyses. So the correlation between attitudes towards smartphone shopping and attitudes toward toward online shopping, and the correlation between attitudes toward smartphone shopping and general attitudes toward traditional shopping. So each of those two correlations, you're going just as before, you're going to provide the correlation statistic. You're going to comment on the strength, the direction, and the significance of each of those relationships and what that actually means. So you can use that general template as we've been through in with the previous objective, and also that technical notation that we've also been through.
Beyond just correlation, when we're looking at those sorts of relationships, there are a number of additional analyses we can do. You don't need it for your report, but it's certainly something that you could comment on as a way to follow up the results that you get. So remember, at the end of your report, you're going to be talking about things like limitations and future directions for research. So a nice thing to comment on might be additional analyses that you could do beyond just saying that two variables are related or two variables are correlated. One of the most important research analysis techniques that are out there that build on correlation is what we call regression, and maybe you've come across that before. Regression simply takes the idea of correlation and goes one step further. It says we know that correlation means two variables are related, but can we then use that data to start to make predictions about one variable if we know another variable? So it does that by allowing us to plot this line of best fit through as many of those points as possible. So it produces a line that sits between as close as possible to these points, each of these points, and it might vary a little bit. And once we have that line, we can start to ignore that raw data and simply say, well, if we score 5 on this X variable, what would that line tell us that the corresponding Y variable would be? And you can think about how useful that could be with something like being able to predict sales based on the level of advertising that you want to spend. So in the past, we might know that spending $10,000 in advertising will lead to $50,000 in sales. We have a whole bunch of these points from correlation. Once we have that regression line, we can say, well, what happens if we spend 80,000 in advertising? Well, we might get 125,000 in sales. If we spend 120,000 in advertising, we might get 250 in sales, 250,000 in sales, and so forth. So that way you can see regression becomes quite powerful as an extension of correlation. We've got bivariate regression, is where we've just looking to use one variable to predict another, where we've got two variables involved, which is usually represented with this, so IV predicting DV, predicting an outcome variable. And then we've also got multiple regression, which is where we have multiple variables being used to predict that dependent variable. So what happens when we use sales to advertising to predict sales, as well as time of year to predict sales, as well as number of people in our store to predict sales, and so forth. And what you'd see is the estimate for sales prediction start to become a lot more accurate. So we've talked about just correlation with looking at relationships, but be conscious that there are a lot more techniques and very powerful techniques beyond that. And again, these are techniques that we look at in AMB 305. So check out that subject if you'd like to know more. So that covers cleaning and editing the data, writing up your descriptives, responding to objective. Within your report, you're going to follow that general layout for writing up those results. Make sure you do that one. Following that, you'll have your discussion section, or your discussion and recommendation section, and this is where you go through and interpret those results. So given that we found the significant difference between men and women, or between age cohorts or whatever, and the relationships between the different variables, or the lack of relationships, what does that actually mean? So is there any implication for practice? Are there implications for theory? Have you found past research that says a different sort of pattern should be found? So you might want to comment on that. Was there anything that was surprising in there, and how could that information be used by a marketing manager? Importantly, you'd go back and think about how should we, or what should we research going forward, or how could we analyze our data going forward now that we've done our analysis and we've got our results. And really that comes back to identifying some limitations, and then thinking about problems with the research, or extensions of the research, and the way you might move forward in the future. So this sort of stuff will be talked about in tutorials briefly, but that's the essence of what you're going to do with your discussion section. Make sure you make the most of that. That's quite an interesting part. And really, if you think back to the definition or description I gave of quantitative analysis at the start of the second video in module 2, it was that data analysis is about producing meaningful information. So it's really this discussion section that is key for using that data analysis to move to that meaningful information type dimension. All right, that's pretty much your data analysis. I will finish off by just reiterating a little bit more about those two additional research units before finishing with the module. So AMB 305 is a third level subject that we've run for a couple of years now, and we tend to have a smaller cohort with this. We try to cap it at around maybe 25 students, because that's where we get the most interaction and students tend to learn best. This is a subject that runs in semester 1 of each year, and where we provide you with training in not only use of industry-leading software packages like SPSS, but also NVivo, which is a qualitative data analysis package, so that you can use computers to analyze your qualitative data rather than doing it by hand. But we also use that as a training ground for building your statistical knowledge, so that you're pretty much ready to move into a research career, or an analyst type career, or at least apply for those jobs and be competitive for them in interviews at the conclusion of that. It's a workshop-based subject and very hands-on, and students learn very rapidly in that, because what we do is use real data and we contextualize it within a real marketing setting and with real marketing problems. In semester 2 of each year, we've got AMB 306, which is Advanced Consumer Research, which is where you as a student are able to learn about research design in more detail, and specifically experimental design, based around solving different real-life marketing and consumer behavior problems. And then by the end of that, you will put together a research proposal to address a problem of interest to you. So that's really quite nice. And we have in the past, based on each of these subjects, put quite a number of students into research positions, and these are 2 subjects that the market research firms that come to us do recruit from. So they're quite handy in that respect if you do want to move into a research career. Again, this second one is also workshop based, and we try to restrict it to about 25 or so. So if you are interested in those, do get in contact with me, or you can speak to HiQ. They're run by myself and also Associate Professor Dominic Greer, who takes services marketing. Typically, if you've had that, you'd be familiar with Dr. Greer. And we use a team teaching approach with those. They're quite handy subjects to take. They're also available to you if you are a double degree student and you think you don't have capacity within your program to take them. We are able to change some of that around in order for you to fit those. So send me an email if you're interested in taking those subjects. So in this video, we've gone through how to address the objectives for the report with inferential statistics, and importantly, how to write that up for your report. Hopefully that takes a lot of stress out of the report for you. It is really quite straightforward. Follow those steps and you'll be fine. I've gone through the data analysis and how t-tests and correlations can be run using a package like SPSS. Remember, you do get that all from the analysis document. There's no need for you to go and do those tests yourself, but you can if you'd like to. And that is pretty much all I have for the module, and that rounds out everything we need to cover for AMB 201. Good luck with your report, and I hope everyone has found the unit very useful.